Hello, my name is John Herr, and I'm a Senior Software Engineer at Red Hat. This video will provide a simple demonstration of the node health check and self-node remediation operators and how they work with OpenShift virtualization. The cluster used in this demonstration consists of 6 nodes. 3 run as control planes and 3 run as worker nodes. The cluster has the OpenShift virtualization operator installed. Remediation should not be confused with migration. Each serve a different purpose. Remediation allows the cluster to repair itself without user intervention. However, remediation does not provide 100% uptime of the VMs. The VMs will be down until the node remediates or until a timeout is reached. Migration is used to move a VM to a different node with little to no downtime as the VM live migrates. Migration is initiated by a user and is ideal for planned maintenance of nodes. Migration is not a method for nodes to self-repair themselves. The node health check operator and the self-node remediation operator work together to remediate issues on nodes. The node health check operator identifies unhealthy nodes and notifies the self-node remediation operator that a remediation is required. The self-node remediation operator remediates unhealthy nodes. An instance of the self-node remediation operator runs on each node. This allows a node to remediate itself if it loses connectivity to other nodes. First, I will show the migration of a virtual machine so that we can better understand what a remediation is. This screen shows a window of the cluster's user interface with a regular user logged into it. It also shows an RDP session into a Windows VM. The Windows VM is streaming an episode of Ask an OpenShift Admin. The last window is the command line. It is used to show which node the VM is running on. We can see the VM is currently running on node WWK-2. Let's migrate the virtual machine to another node. We can now see the virtual machine is running on node WWK-0. As you can see, there is only a slight pause in the virtual machine, and we can see the virtual machine is still running. Now let's look at remediation. The installation of the node health check and self-node remediation operators is easy to do through the Operator Hub. A simple search in the Operator Hub will show 2 versions of the node health check operator. We will be using the one provided by Red Hat in this video. The node health check operator will automatically install the self-node remediation operator if it is not already installed. After the operators are installed, they will immediately begin watching the nodes and remediate any issues if encountered. Configuration is done in a node health check. A default node health check is created during the installation of the operator. Looking at the YAML shows the default configuration. The min healthy parameter controls how many healthy nodes are required to perform remediation on unhealthy nodes. The purpose of this configuration field is to protect against killing a massive amount of nodes unnecessarily for issues like switch failures. The default value is 51%, but may need to be changed based upon the size of the cluster. The name parameter under the remediation template section indicates which remediation template of the self-node remediation operator to use. The unhealthy conditions section controls when the node health check operator notifies the self-node remediation operator. The default value is 5 minutes. Let's change that to 1 minute for this demonstration. Currently, the node health check operator only works on worker nodes. Control plane remediation should be available in a near future release of the operator. The status section shows the status of the nodes and if a remediation is triggered. Please see the documentation on the operator for more explanation of its configuration. A link is provided at the end of this video. Now let's look at the self-node remediation operator. Currently, there are 2 remediation templates available. These are the templates identified in the node health check configuration. The node deletion template will be deprecated in future releases of the operators and should not be used. The configuration for the self-node remediation operator is also done in YAML. The configuration parameters can be adjusted as needed. The save time to assume node rebooted seconds parameter is automatically calculated. If the calculated value is too small, a larger value can be specified. Please note that the operator will use the larger of the calculated value or the specified value. A link to the formula used in the code is provided at the end of this video, as well as documentation on the configuration parameters. We will not make any changes for this demonstration. The Self-Node Remediation tab shows any ongoing remediations. Currently, there are none. Let's set up a few things to monitor the impact a remediation has on VMs. First, let's monitor the cluster node that the VMs are running on. We see that the node is currently in a ready state. Let's watch the VM status. We see that all the VMs are currently running on the same node. We have 2 VMs running Red Hat Enterprise Linux 9. They are simply running a loop to display the time. One VM is connected to the default cluster network, and the other is connected to a second bridged interface on the worker nodes. We also have 2 VMs running Microsoft Windows 11. We will watch one of my favorite episodes of Ask an OpenShift admin on each VM. Just like the Red Hat Enterprise Linux virtual machine, one VM is connected to the default cluster network and one is connected to a second bridged interface on the worker node. Now, let's cause a failure on the worker node running the VMs by stopping the kubelet service on the node. We can watch the status of the worker node. It should enter a not ready state shortly after stopping the kubelet service. Once the node enters a not ready state, the node health check operator will wait a little more than a minute before it notifies the self-node remediation operator that remediation is needed. We can see that there is currently no remediation initiated. The node has entered a not schedulable state. This means a remediation has been started. We can see the remediation has been initiated. We can also see that the VMs have stopped. Currently, the self-node remediation operator should be trying to fix the issue. The node will reboot as part of the fencing process performed by the self-node remediation operator. The node has entered the ready state, but still has scheduling disabled. Now that the node has entered a schedulable state, the VMs should soon be rescheduled onto another node. Waiting for the remediated node to come back up into a ready state is done to prevent 2 VMs from connecting to the same PVC. This helps prevent data corruption. We see that the VMs are entering a running state. This does not mean the OS inside the VMs is up, just that the VM is starting its boot process. The VMs are up and running after giving them a little extra time to boot. Please take notice that the VMs are new instances. The failure essentially causes an abrupt power off of the VMs, similar to a power failure on a physical server. I hope you enjoyed this demonstration and maybe learned a little. The 2 operators work with OpenShift virtualization to help keep your VMs up and running. Although this is not a zero downtime solution, it should allow the worker node and its VMs to come back online quicker than manual remediation. I have included several links to some great information concerning these operators as well as OpenShift and OpenShift virtualization in general. Thank you very much for your time.